terms. Okay. So in general, we have it. The first thing we have to understand that we are actually having a system where we basically have a mass on a horizontal smooth surface. There is a logic behind telling it's a smooth surface. That means it can move. That means if it can move, it will have a kinetic energy. And we have got another mass m, which is actually connected by an inextensible string of length L, and that is the mass small m. So this capital M and this small m will comprise the system. So that means if we actually want to find out the Lagrangian of the system, we actually have to find out the kinetic energy of both the masses, potential energy of both the masses. So there are two options and we have to choose which one is the correct one. Okay, so in general what we do is first we write down the Lagrangian without looking into whether this is p theta, px, what they are exactly asking. Let's just find out what is the Lagrangian. So for that we are going to find out what is the kinetic energy of the larger mass and the kinetic energy of the smaller mass. Okay, so the aim is to find out the Lagrangian. So for that, let's find out the kinetic energy of the bigger mass. So I'm saying that this is actually at a distance x, so that means this mass is also at a distance x. And then there is a logic behind telling that neglect the size of the masses. If I don't neglect the size of the mass, that means even I have to consider this distance. It will become a bit more complicated and it might not tally with whatever options are given here. So that's why we neglect the mass. We say that this distance is very small. So we just say this is x. So that means if this is the distance, we can simply write down what is the kinetic energy. So this is half m x dot square. So that's the kinetic energy of the bigger mass, right? Now we have to find out the kinetic energy of the smaller mass. Now for that we actually have to do certain things here. The first thing is I have to find out what is the displacement along the x direction and the y direction, because it says that it can actually oscillate in the xy plane. If it oscillates in the xy plane, there is a displacement along the x-axis and the y-axis. So let's say along the x-axis it is x, and so this x is equal to capital X plus this distance. So it is L sine of
theta.
and y, okay, is this, and this is nothing but L cos theta. We already have it here as L cos theta. But we need velocity, so that means we have to just take the dot product of that, right? So we can just take x dot is equal to x dot L plus L sine of sorry, no dot I'm sine of theta, ddt of sine theta. So that means this will be L cos of theta and then cos. Okay, so if we differentiate that, we'll get that. And then we have got y, and for y we have to take the y dot here, the velocity, because we want to find out the kinetic energy. This will be nothing but ddt of cos theta is minus cos sin theta. It will be minus L sine of theta. Okay, so we just do it directly. Therefore, what we can do is we can find out what is my Tm. So my Tm would be half of m small m, and this is x dot square plus y dot square, and that's the reason we actually finding out x dot and y dot. So we have it as half m and then x dot square. So that means I can just expand this maybe small x square. X dot square, and x dot square is this, right? We're expanding this. X dot square plus L square cos square theta dot square plus 2 times of x dot L theta dot cos of theta. Okay, seems like it's going to be a bit long. Then I think I've taken the task of solving it completely, so I'll do it. Okay, plus y dot square. So let's just do plus y dot square. Y dot square is nothing but this term. So I can just take it to be L square sine square theta dot square. So I can combine this term and this term. Inside bracket will be sine square theta cos square theta, and this will be L square theta dot square. So it will just be 1 there. Okay. So that means maybe did not organize it properly here. So this will be half of m, and then this would be nothing but x dot square plus L square theta dot square. I've combined the sine term and the cos term plus 2 x dot L theta dot cos of theta. That's my kinetic energy of the the smaller mass. So that means now I can write down L as kinetic energy of this minus kinetic energy of small mass minus the potential energy of the smaller mass, right? We do understand that potential energy of the larger mass is equal to 0. So I'm not just explaining this. Yeah, and so and this is small m, this is capital M, and there is an x dot square with both, so I can just take this as small m plus, just writing it down directly, x dot square, done with this first part, plus, okay, and this will be half m, then I take the remaining term, L square theta dot square plus 2x dot L theta dot cos of theta, right, that's it, minus, yeah, Vm is minus mgl cos theta, so I'll just put a plus, and then this will be mgl cos of theta, right? So that's my Lagrangian. Once I have my Lagrangian, I think we can do it easily, right? It's easy. So you can replace image or something. Okay. But anyway, I think we don't need to even do anything here. So see this, yeah, px, right? We have to just find out what is the px. So let me just do again. Difficult. We have the Lagrangian. We can so px is nothing but del L del x dot, right? Know that already. So what is my x dot here? This is one term which is the x dot. So if you take it, this is 2x dot. This 2 will get cancelled. So I will just have it as m plus capital M x dot. Got the first one, right? Then everything is plus here. So I'll just put a plus. So we have an x dot here. We don't have an x dot here, so this is not to be considered right now. Don't need it. There is no x dot here, so this also is 0. So this is only x dot. So we can take this. This is this ddt of x dot. No, dt del del x dot of x dot is nothing but just 1. So whatever is remaining will be there, right? So you have got half here. There is a 2 here, so that will get cancelled. But anyway, let me just write it down. Half m, small m, and then we have got 2 times of yeah, theta dot cos of. So this 2 and 2 will get cancelled, right? What we have is so m plus m x dot plus half is not plus, sorry, is L, and then there is a m, then there is cos theta, and there is theta. So that's why we say that this first option is correct, right? So we got this is absolutely right, and this is the detailed way of doing it, okay? But in exam also you cannot use too much shortcut, even if you do it with some mental maths. You should be careful that you don't miss the steps, that's important. And apart from that, p theta, I think straight away we can see that this is actually wrong, because we just take del L del theta dot, okay, del L del theta dot, okay, so we have it here, and this term is not there, and here you can see it's there, but okay, and then it's theta dot here, and then you take a cos del del theta dot of this, right? Yeah, so there is an x dot here involved, okay. I think there is some mistake which I did. Can someone tell me what's the mistake here? It seems like del del theta dot is also coming out correct, which it may not come.
That when you take
Yeah.
this only the stable point, no?
Uh-huh.
X equals to constant shift, no? Where we
X
take
is
X is X and
सर टू एक्स डॉट का जो आप डेरिवेटिव लिए एक्स डॉट के
uh-huh.
साथ, तो वो एक्स डॉट कैंसिल हो जाएगा ना, वन हो जाएगा वहीं पे सर, वही लाइन में नीचे नीचे।
This one?
हम्म,
No, no, what you are saying is that I'm not getting it. Yeah.
सर ठीक है आंसर, ठीक है सर, सर आई हैव,
Yeah, PX is correct.
ठीक है सर, ठीक है सर।
The PX is correct, right? Yeah, yeah. We'll just look into del L del theta. Let's see whether this is correct or not. The first part is obviously not there. And then we actually have it as ml square theta dot. So this is okay. Ml square theta dot is fine. And then we have got one more theta dot here. We have got one more theta dot here, right? And if we just differentiate this theta dot, what we have is a plus here. Okay, and then we have got half of, and okay, now here I'm not sure whether I'm getting it correct or not. Let's see. 2x dot L del del theta dot of, this is there. So it will just become 1. And then we have to take the del del theta dot, okay, no other term is there with theta dot. So this is 2xl cos of theta. So this 2 and 2 gets cancelled. This is ml x dot cos theta. Okay, yeah, even p theta is correct. Okay, so check this. So I guess because I looked into the the answer key, probably in the answer key this was not plus. This was, I mean, in the question it was not plus. This was minus. So I've written it plus. So this is plus. This is correct. If this is minus, this is wrong. Okay, yeah, I think that is the reason that I'm not able to match it with the answer key. So I did check the answer key with it. So yeah, this is the reason. So this is p theta is also correct. So if I have given you this option and none of you got p theta to be correct, that means you have done something wrong there. Okay, this is actually correct. Plus it's correct. If it's minus, it's not. And px and p theta are is conserved and this is not conserved. I've already explained it. You can also do it if you have your L here. Easily you can see that px is conserved because you just have del L del x dot minus del L del x. There is no del L del x down here. You see, it has got an x dot here. There is no x here. It is x dot here. There is no x here. There is no x here. So del L del x will be 0. There is no del L del x. This del L del x dot is here. And that's the reason that px is actually conserved. Okay. On the other hand, p theta is not conserved because it does have a term of del L del theta from this final term. Even if it has it here also. We cannot get it conserved. Okay. So that. So, it's by now we all understand that solving a problem on Lagrangian actually is all about designing the Lagrangian. If you have a topic on Lagrangian and Hamiltonian and you're supposed to solve a question, the most important task is to design the Lagrangian. If you can design the Lagrangian correctly, probably you'll get your answers correct most of the time. It will not be a problem. Okay. Okay. So before I end, I have got one more question. Okay, this is also there in Gate. Okay, and this is actually for a wedge problem. Okay, I'll give it to you and leave it up to you. I'm not going to solve this. I'm also not going to give you an option for this. So what happens is we basically have a surface. We have a surface and we have a wedge here. Let me show the image first. And then we have a mass here, mass m, and this mass is m. Mass of the wedge is capital M. The height is h. And this is a smooth surface. So that means even the wedge moves. So that means same as before, the wedge will have a kinetic energy of its own, okay, and then it will have the angle theta. So the approach is not very difficult. Okay, and it says that this mass m can slide, okay, through the inclined plane, right? Through the inclined plane. That's the first information. that is being provided, okay, inclined plane on the wedge. And then we can see the wedge has mass m. The wedge has mass m, okay, and can also slide, okay, can also slide on the horizontal surface. And that will come back to us. Okay, no friction anywhere. There is no friction. No friction. Yeah. So we don't have any kind of friction there. Okay. So what you have to do is, I'm not going to give you the option. You have to find the Lagrangian formula and equation of motion. So I'm leaving this to you. Okay. I expect this that you can solve it. Okay. You know, if you just find the 2021 question paper, you'll get it there also.